So Creamer Media's Mining Weekly Online is talking to Rod Pickering. Tell us about this controlled foam injection and how it breaks rock.
You know, I've spent nearly 40 years looking at different ways of breaking rock and different machines to do it with, and ways to improve our narrow reef hard rock mining industry. Right now there's a huge amount of effort going into developing rock cutting machines. But you know, all those rock cutting machines, they're expensive, they have high capital, and they're also expensive to operate as well. They have high operating costs. This foam injection as an alternative way of breaking rock is incredibly simple. It's very, very flexible. And basically it breaks rock in much the same way that explosive breaks rock. You drill a hole, and with explosive, you put an explosive in there, you put a timer, and you fire the shot and you break the rock. With foam injection, you drill a hole, you put a probe into the hole, you then seal the end of the probe, and the seal is very, very effective and a very, very important part of the technology. We need to be able to keep the foam in the hole under high pressure. And when I talk high pressure, by the way, I'm talking in the region of 50 to 60 MPa. Now, bear in mind that a lot of our rock has a compressive strength of 200 to 250 MPa. So if you're going rock cutting, often you have to overcome that compressive force. But the tensile strength of the rock is somewhere between 5 and 10% of the compressive strength of the rock. So the tensile strength of that rock would be somewhere more like 10 to 20, 30 MPa. So we're drilling a hole, we're putting the probe into the hole, we're putting a seal around the end of the probe, and then we're releasing high pressure foam, 30, 40 MPa, into the bottom of the hole. And that generates a tensile fracture from the bottom of the hole. And that fracture, as part of the way fracturing works from the bottom of the hole, it curves round back to the surface, and you break out a big slab of rock. That's the way it works. And it's as simple as drilling and blasting. I've stood in a mine in Colorado where some of the first prototypes breaking was taking place with foam. And we'd been breaking into a face, and I was standing 3 meters away from where the breaking process was actually taking place. And I stood there and watched the foam break the rock, eject the rock off the face. And I wasn't assailed by any noise. There's no loud bang from the explosive. There was no dust. And there was a little bit of fly rock, but I was standing a little bit to one side and absolutely safe. So it's a gentle way of breaking the rock. Foam is a mixture of air and water with a little bit of soapy material in there to change the way it behaves, so create a foam, just as you do when you're washing up. You want a foam, want a surfactant. And so now we have foam, which means we can store energy in the gaseous phase, and yet not so much energy as you would do if just using gas. So we can controlled foam injection, we can control the pressure, we can control the foam mix to give us a variety of breaking characteristics that happen in the rock. So depending if the rock is intensely fractured, for example, we'd use probably one type of foam. If the rock was just solid, we may use a different type. We may use different pressures. We need to experiment with these various conditions in the various rock conditions that are dealing with it. But that's why foam works where gas doesn't work and where water doesn't work. Foam is the middle road and works very, very well. There's no chemical reaction at all. This is totally inert. It's inert, it's non-toxic, it's just a little bit of soap and water and air. I see this as a replacement for small diameter, short hole drilling and blasting. So this to me is a new way of mining the hard rock. Whether it's tunnel development or stoping or virtually anything you want to do with small diameter short holes, this is doing it differently. Is that what we need at the end of the day is a safer, more cost-effective mining industry. And what, in my view, the OEM should be looking at is what are the technologies we could use to make the industry safer and more cost-effective. And in this case, as I say, use this foam as a rock breaking device. We could operate 24/7. You know, if you look at a typical narrow reef mine today, we're operating for maybe 25% of the totally available times. If we operated that asset for, I don't know, 100% of the available time, then we could just be so much more productive in what we just wouldn't need so much space to do all the mining in. We could concentrate the mining into a much smaller area because we could get more production out of each area. And in that way we could get better ventilation, get better services, get better management control. We could just generally create a better environment. And of course, if we're going to be doing this as a breaking method, we're going to be mechanizing. I mean, this is not going to be somebody out there with a hand drill drilling a hole and then taking this big cylinder and pushing it in the hole. This is going to be a machine which is going to drill the hole, index round, insert the foam injector probe, seal it, release the high pressure foam, and boom, we're going to be breaking the rock. So this is going to be a continuous process. And then obviously we need to match that with a carrier, with taking the broken rock away and installing support. The potential in the civil engineering environment is just as big as the potential in the mining environment. And not just narrow reef hard rock, by the way. Although I think in narrow reef hard rock, we could use it for development and stoping. But in all the other underground mining operations in hard rock, you have to do development. And what do you want? One machine that does 50 meters a day, or 10 machines which do 5 meters a day? I mean, it's the way, that's the future for me.
That was Creamer Media's Mining Weekly Online, speaking to Rod Pickering of Pickering & Associates about controlled foam injection.